Okay, so what I'm going to do is show you guys how to use Tracker right now. Now, if you are currently using your personal computer, I'll also show you how to quickly download it. It's a free program. It does not work on Chromebooks. It just takes way too long to load videos. But if I'll show you real quick. If I go here and just go to Google and I type in physics, let's change that, physics tracker. What we get here is physlit.org tractor video. Click that. There's technically an online version that kind of works, but if you have, Mac OS or Windows, just click one of these and install it. There's lots of capabilities, but basically, once you install it, it just works. It's free. It updates. It updates often. But anyway, this will make it so you don't have to sit here in my classroom and do these labs all day if you want to just go home and do it instead. Anyway, once it's installed, it looks like this when you open it. I could go File, Open, File Chooser, and select my videos. Or what I like to do is I literally just like dragging this over here. Give it a few moments here to load the video because it's not exactly the fastest thing in the world on this computer. Let's see. And yeah, this is what we get. As you guys can see, I accidentally um, zoomed in a bunch. All right. So what we'll do now is we have our scene. When we take our video, you want to make sure that the video is parallel to the scene. You want to make sure there's something on the objects that are going to be moving, or sometimes a single object is going to be moving, that's easy to track. You don't want your camera to move. But most importantly, you want to make sure you have something in the scene that you know the size of, so you can tell the computer what's the size of every object. Like, how big is this car? How far did the car move after so much time? It can't know that if you don't do that. So what you can do is up here, this blue button right here, don't click the one here that's green. This just allows you to measure stuff. What this does over here is this allows me to go new calibration stick. Like I said, this is the thing we use. Now, I can't see the ends of my meter stick, so I don't have to use the whole meter stick. I can just sort of place it somewhere. I'm going to zoom in a little bit so it's easier to see. Let's go 200%. And I'm just going to bring it over here. And I can kind of tell that, let's see, this is what? This looks like 10. This looks like 20. I'm just going to sort of line it up. My lighting wasn't best on this video, so you could always do better. But I know the distance between those is approximately zero point 0.2 meters. And now the program knows the size of everything in the scene. This seems like it took me a while, but like I said, ultimately, if you do this a few times, you're going to be doing this really fast. I'm going to zoom back out real quick. Okay, next thing I want to do is, just like anything in physics, we need to set up our coordinate system. This pink one right here, the little 90-degree angle things, that's an X and Y coordinate system. Okay, now sometimes I'll put it on the car or the other vehicle. Wherever I put this, that's going to be 0. 0, comma 0 is that dot. Just for the sake of making this look nice in the data, I'm going to fast forward the video, and wherever the cars collide, I want that to be 0, just because this is a collision. And see, I'm having trouble getting exact. If I go over here to the right, we can move forward or back a single frame. So I'm going to go forward a frame until the moment they collide. I'm just going to kind of stick this in here somewhere and go, that looks to me like a good place for 0, comma 0 on the graph. All right. And then once again, I always want to make sure to rewind my video back to the beginning. Okay. Now, second thing I'm going to do, the point of this lab right here is we want to know the momentum of the car 1, momentum of the car 2, and we want to see if momentum is conserved after the collision. So I don't care about their hands being on it. So what I'm going to do is I'm going to click this little black arrow here. I'm going to drag this forward. This is cropping the video. So, and you can see I'm at the point now where both their hands are off. Okay, we're good. And similarly, I don't want the end of the video to be where you can see the camera moves a little bit, to be where they're touching them either. So I'm going to go to about here, and I'm going to drag this black end over here. Remember, the black ones, the black arrows crop the video. The white arrow just allows me to scroll through the video. And this right here, if I click this over here, it always resets me back to the beginning of that. Okay, anyway, so we got this. I could tilt this a little bit. If you click over here, when it becomes a finger, it doesn't work anywhere else except for past this line. You could rotate this, but it's really hard to do. I sometimes prefer just to go over here and go, okay, I need this to come down on this side. So that's like negative, let's say negative 0.5 degrees or something. It doesn't have to be perfect, but I just it kind of bugs me when it's not. All right. Okay. So what I'll have students do most of the time is I'll have them mark their cars with a piece of blue painter's tape or red tape. And for this type of lab, everyone marked them in the middle. It would be better if it marked it in the front though, because we want, when the cars collide, we want the two graphs to look like they're colliding almost. And you'll see what I'm talking about in a moment. So what I'm going to do is I now need to identify what are the things that I'm tracking. We know distance, right? We know what's up and down and what's left and right because of our coordinate system. The other thing I want to do before I do that is I'm going to go to video and go to clip settings. Okay, this is a slow motion video I took with my phone. Sometimes I have students look it up if they have a weird phone, if they're doing slow-mo. Slow-mo is always better, more frames, more data. This is not 30 frames per second. This is a slow motion video. I know with my Samsung 20 or 20 plus that if I do normal slow motion, not ultra slow mo, I will be at 240 frames per second. Hit enter. What this does is it makes it sure that my time axis on the graph we're going to get is in the right units. It's not, if the cars are moving, I don't want it to think it took literally 60 seconds to move a meter when time is actually supposed to go in slower. Anyway, click OK. Okay, now the real part. New point mass. Okay, opens the graph. It says mass A. Well, how much is mass A? Well, I weighed these cars. Now, you don't always need to know the mass for some things, but for this lab, we do need to know the mass. I know it's about 2.225 kilograms per car. Okay. And then what I'm going to do is we're going to go, you can see it down here where it says, this yellow, set mass on toolbar, shift click to mark. So what I'm going to do is I'm going to mark in the same place I'm going to track. I'm going to hold shift and I'm going to click. I'm going to try to click at the front of the car here. Hopefully the green here, we don't want, when you start to auto track, we don't want this thing to move around. So this is why you like to have a piece of tape. I could put it on this end, but then I have this gap between the front and the back. And in my data, it's not going to look like the cars collided. So I'm just going to kind of pick over here somewhere. That may not be the best spot. We'll see in a moment. But if you notice, it put a data point over here. It also moved forward one frame. Okay, so to make the other car, I need to actually go back to the first frame again because we don't want the other car to be missing the first frame. So new, track new, point mass again, hold shift. I'm going to click the front. This one's a little easier because it has a little white 3D printed spring holder we put up there. Click that. Good. Now we're on mass B. We can switch between them. Mass A, mass B. Okay. Now for this graph, I want to see both mass A and mass B on the same graph. Okay, that's kind of hard to do normally. So what I'll do is I'll right click when I'm on mass A, go down to compare with, and I can actually make it, if I do compare with B, you guys see there's two dots on here now, one at this location and one at this location, 0.6 meters that way. This one's about 0.6 meters over here. This now means we're going to see both. Y-axis, nothing's going on in the y-axis. So what I'm going to do is I'm going to click this. Look at all these options. We have angular velocity, acceleration, displacements, and some kinetic energy. What I'm going to do is I'm going to select momentum in the X. We only care about momentum in one direction. Don't click momentum magnitude because then your positive and negative momentums will become the same direction and you won't see any crossover. So I'll just click momentum in the X. Sweet. And then once again, I'm going to right click, compare with, mass B. And now we have both sets of graphs. Okay, now what I'm going to do is I'm going to go, now that we're up to this point, I can go to track, and now we can start doing the actual tracking. I know it was just spent forever just setting up, right? Mass, oops, I did not mean to click that. Track mass. We're going to go mass A. We're going to go down to auto tracker. Now there's a shortcut here. We could have just hit shift control, but I want to do it the full thing. Here's auto tracker. Okay. You don't really need to mess with these most of the time. This is just how sensitive the tracker is. But what I'm going to do is if you read over here, it says to create a new frame, shift control click the video feature of interest. Mouse over the controls above, lower, yada, yada, yada. Basically, I'm going to shift. So here comes a square again. But if I hit control, my cursor becomes a circle. What this is doing is it's literally selecting the pixels. As you can see in the example right here, it's selecting the pixels it's going to look for in every frame of the video. And as the video goes forward, it knows how long it takes, how long each frame is, and it knows how far the object moved because of our scale we did right here. We're able to find distance and time. And like most things in physics, most every measurement you ever take is just a manipulation of distance and time, velocity, acceleration, momentum. If you can measure the mass of an object, you can find momentum, energy, rotational information, all sorts of things. Majority of it is just distances and times modified. Anyway, so now what I'm going to do, now that I've shift collected that, I'm going to move this out of the way so you can kind of see what's going to happen. Okay. We're going to cover car 2 or car B right now because we're not really looking at that one. We're just looking at car A. Hit search. And as the car starts to move, you can see the graph builds. The momentum graph doesn't build. I think it's because it has to multiply by mass, so it waits till it's done. You can see the little cursors moving as it goes frame, 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 frame. Different computers will do this at different speeds. This is my work computer, so it's not the fastest thing in the world. You can see it's mostly a straight line. We are getting a tiny curve. There's a little friction slowing us down, so we have a little negative acceleration going on. Okay, and as we approach, we're going to have an impact, and let's see, can we see the impact? Boom, and there we go. We have this inflection point right here where the velocity goes from positive to negative. The slopes look fairly similar. I'm going to wait here for another moment here. We should get there in a second. Sorry this takes for so long. We'll just let it go. Maybe if I figure out how to edit this video, I'll fast forward this part. You don't have to hear me ramble nervously. But this looks good, right? I mean, we have 2 identical cars moving at close to the same speed, colliding, and we have the momentum out as that. Now, of course, I'm sure you're asking, wait, you did 2 cars. Why don't we only see 1? Well, we have to manually go back and do the other car now. But look at this. This is mass times velocity, right? This is momentum, kilogram meters per second over time. The momentum of the car, it slows down a tiny bit, but for mostly it's pretty constant. And then you have this sudden drop in velocity. Well, look, we're positive, 0.15, and now we're negative, about 0.12-ish. If you cover over these, you can see the numbers a little bit. Yeah, 0.12. Let's see what we get from this one. There's a point way over here, and I think it's because maybe where I started, things were a little off. But that's all right. Let's do number 2. So what I'm going to do is I'm going to drop this through mass B. Okay. Once again, mass B, don't make the mistake I did before. You want to rewind this back to here, or you're just going to get 1 frame for mass B. So you always have to go back to the beginning of your section. And now what I'm going to do is, once again, just like it says, shift, control. We know we're good when we have a circle instead of a square. Click on that spot. There we go. Click on the spot. I can't shrink and grow the spot so it doesn't. Sometimes when things are kind of the same color, your spot could jump all over the place. Okay. And at the end of the video, I'll tell you some problems we have with different types of videos. Like certain iPhone video formats have issues. Certain, and there's some videos that we actually can't track at all. And we'll talk about that at the end. Anyway, I'm going to click search. Look, now you can see this graph is starting to grow. And once again, this is going to be a bit of a waiting game. But it's nice. It's like an animation. You can see this is the distance and time of the first car. the slope of this, as you know, is velocity. And then the distance and time of this car, slope of this is velocity. We should see, based on the rules for momentum, that momentum is not just conserved in an elastic collision, momentum is exchanged. This object's momentum becomes this object's momentum. And you'll see why here in a moment. And those are pretty close. Boom. Little tiny gap there. That's just because, these spots aren't exactly on top of each other. That's like the distance between our two selection points. And once again, you're not going to see this graph until it's done. But this is great because now if you trace this blue line, and if we got rid of this little gap and shifted everything up or down a little bit, you see that this blue line would actually almost carry on into this red line. And this red line would carry on into this blue line. Or in other words, momentum 1 initial plus momentum 2 initial equals momentum 1 final plus momentum 2 final. Or if you want to get mathematical, m1v1 plus m2v2 equals m1v1 plus m2v2 final. Conservation of momentum. And of course, the slopes are slightly off because we don't live in a perfect world. We are losing a little velocity, and the tracker's not perfect. But now look at this. Oh, absolutely beautiful here, right? This car comes in, hits that car. Now you see car one, it goes from, like 0.1-ish, a momentum of 0.1-ish to a momentum of negative 0.1-ish. Oh, I know why. This is my fault, guys. Look at the mass of car two. I accidentally made car two heavier than car one. So if we go 0.225. Now, sometimes if you do this, it won't change right away. It'll take a really long time. Notice the graph didn't just jump up. But what I can do is we can get stuck. Instead of looking at momentum, let's look at velocity. Remember, momentum is just mass times velocity. So we just took mass out of the equation. There we go. This looks good. This car was going this fast. Now it's going this fast. This car was going this fast. Now it's going this fast. This car's momentum became this car's momentum. This car's momentum became this car's momentum with a little bit of loss. Looks primarily in a little bit of a shift actually, because this one's a little lower than that one. So they're pretty even. But what's great about this is this right here, this line, this is impulse. This is the change in momentum. This is saying this object had a change in momentum of force times time. This object had a change in momentum, force times time. But this object's force is equal and opposite to this object's force. Therefore, for the whole system, the change in momentum is 0. So it's just momentum plus momentum equals momentum plus momentum, and that the final and initial are identical. There's no change to the system. Now, if we were to get rid of one of these and only look at this one, or only look at this one, we would see that for an individual object, remember, a system is whatever we decide to draw a circle around and say this is our system. If car one was our system, then car one we would say, oh, momentum's not conserved. There's something from the outside, right? An open system, something from the outside that changed our momentum. And same thing with this. Something on the outside changed our momentum. But if we have two cars as part of the system, we can see that all effects cancel out. Anyway, so this is nice. Now I'm going to add a couple little things here. So this is kind of where we're done with this lab. But I want people to know how to do more things with this if they need to. So for instance, if I want to copy and paste this, I right click, I can copy the image. I can take a snapshot, which allows me to take, it gives you more options for your images. I can also, let's say display, not a lot of options. I can save it as a picture file, or I can just copy and paste it into Docs or Word. But I think one of the more powerful things we have for this is we have Mass A selected. If I right click, I can go, let's go analyze. There it is. Whoo, boy, I analyze and there's way too much data up here. So what I'm going to do is I'm going to get rid of the things I don't need. Just because I had this open before I showed you guys how this stuff works. Let's go. Okay, so let's do just distance and time, and then let's do, yeah, distance and time. Um, let's see. This is not working the way I wanted it to. I was hoping, yeah, let's just not do this. Let's go to Mass B real quick. Okay, Mass B is easier to look like. Okay, I zoomed this in, by the way, a ton because I wanted to have a really clear look at the data. Let's zoom it out the way it was. This is one I did earlier, same video and everything. But look at this. We have this to this. If I highlight, for instance, let's highlight these. Right now I have, this is Mass 2. I could do the same thing in Mass A. But if I highlight this, I can analyze and I can actually do curve fits. I did a line fit because I kind of wanted to know what was the change what was the change of velocity. This is mass times velocity 1, mass times velocity 2. We got the line right here, and we get the equation. We know the equation of a line, if we're solving for change in velocity, is velocity is equal to acceleration times time plus initial velocity, right? Or whatever, this is final, this is initial. But this A here, this acceleration, that's the change in velocity times time. Well, that's this, right? So you could use this to figure out what was the impulse, right? Because mass times change in velocity or force times time is impulse. Well, if we know the mass and we know the change in velocity, we know impulse. If we divide by time, which we know right here, right? You just look at our time axis. That would give us the force. We would have the amount of force, or in other words, we have the acceleration, and we can use that to find the amount of force here during the impact. And we would find that this number is pretty close to what this one is, but opposite. Anyway, this is some of the tools you can use. And you can see there are many options for curves, line, parabola, cubit, all the way. And if you don't like those equations, there's a fit builder. You can write out your own function in here. So this thing is not super limiting. Only thing I don't like is if you create new graphs, it stacks on top of the old graphs, and you have to go in and manually delete them. Anyway, close this. So yeah, that's how you use Tracker. Um, and I'll leave you with that. There's obviously more stuff in here I could show you. It works. We've done projectiles before. Um, Clone allows me to make copies of things. One of my favorite things in here is, where is it? It's under help. Yeah, Tracker Online. So what there is there's a large system of example videos, example tracking things for all sorts of scenarios that a bunch of people have made that you can actually just sit there and put in and play with. Or if you don't have access to this equipment and you don't have cameras and stuff, you can just show students or show people um, examples that have already been made and how to track them. And once again, this is kind of cool because I did this measurement here. If I pull out this measurement tool, tape measure, I could now measure something like, okay, if it knows the size, oops, got the wrong thing there. If it knows the size of, let's say, wow, I really want to grab this ruler and it's not letting me. There we go. Let's say I want to know the length of this car, right? It says the car is, ooh, don't zoom in that much. The car is, I don't know, let's say the car is about, see how the number changes? Because now that we have a reference size, this now becomes something we can take measurements of things in the scene. I could measure the width of this, the length of this. Now there is a little parallax because we have angles and we have perspective issues, and some cameras, if you zoom out too far, you have some curvature of the scene from the lens. But I could find the length of this pencil. Of course, we'd want to measure most things in the front of the scene because as things are farther away, they look smaller, right? Anyway, so yeah, this car is about 0.33 meters, which is 33 and a third centimeters approximately. And actually, I know that's true. I've measured this. This is about zero point 0.3 some meters. So this works. This works well for taking measurements. And like I said, it's not just for one-dimensional things. It could be two-dimensional. Maybe not three-dimensional. Three-dimensional is tricky, but it does rotation, as you guys saw with this. You have a bunch of other options. Anyway, just want to give you can also do graphs of the objects. I've accidentally graphed this before, this coordinate system moving around on accident. But yeah, you're kind of just limited by what you can imagine you want to do. There's different ways of calibration sticks, there's calibration points. Not really sure what that does. Nope, zoomed in anyway. All right, I'll leave you at that. Just know one of the hard things, one of the weird things about this is when you save things, you can save a tab. These are the tabs, kind of like sheets. Down here you have different tabs. Save video, save tab. But I like to save project, especially if I have a bunch of videos. Like with Momentum, we take as many as 10 to 14 videos of different combinations of collisions that we come up with. And then we have this, which is the auto tracker data, this thing right here. Anyway, I'll leave you with that. And let me know if you have any questions. Thanks.